Okay, this is another dimensional analysis problem where we convert from moles this time to molecules. Understand that the term molecules can be used interchangeably with the words atoms or particles. It just means that you're talking about a compound, so therefore we use the word molecules rather than atoms. If we were talking about just one element like sodium, we'd use the word atoms or particles. Anytime you see the word molecules or atoms, it should indicate to you, oh, I'm going to have to use Avogadro's number, which we learned was 6.02 times 10 to the 23rd molecules, and that's always equal to 1 mole of anything. So since we're going to start by writing down the given, 3.4 moles of sodium fluoride, all right, I'm going to multiply where 1 mole is going to go on the bottom. 1 mole would have to be on the bottom to cancel out the one on the top. So this is numerator to denominator. All right, this conversion factor always has to be a true statement. So you've got to ask yourself how many molecules would be in 1 mole of anything. And it's always Avogadro's number of molecules. All right, so Avogadro's number of molecules would equal 1 mole. All right, now the part here is simple, just to calculate 3.4 times 6.02 times 10 to the 23rd. Sometimes students will have everything set up right, the work set up correctly, and then they don't know how to punch it into their own calculator. You've got to know how your calculator operates. That's why I like these little TI 30XA scientific notation calculators. These are scientific calculator rather. These are easy to calculate or punch numbers into. So I always put 6.02 and use the EE button for times 10 to a power 23. So do 6.02 EE 23. I like to hit equals just to lock that number in, times 3.4 equals, all right? Now your calculator is gonna give you an answer that looks like this, 2.0468 and a 24 like that. We don't ever write that down on paper that way, all right? So you want to actually write it as 2.05, I'll just round it up right there, times 10 to the 24th molecules of NaF, all right? So that's how you would literally write this calculator answer onto your paper. And I'll let you round up a bit, so we threw that 8 out and just rounded up the number. So 2.05 times 10 to the 24th molecules of sodium fluoride. So that's how we converted from moles to get molecules. We had to use Avogadro's number. It didn't ask for grams, so we don't even have to look at the atomic mass. We just have to use Avogadro's number to get the answer to this particular problem.